Hello everyone and welcome to lesson 19, also about hypothesis testing, this time about means or averages. So, using a 98% level of confidence, test the claim that high school GPAs have a mean of 3.0. And then here's the sample evidence. So there was 33 high school students, their average GPA 3.28, and then the standard deviation. So for the claim, that is that their high school GPA, so this is talking about their average GPA or the mean, and then it's saying that it equals a 3.0. So the claim is that the mean equals a 3.0. And the rule for H1 is that it cannot have an equals. So if this one has an equals, then cross it out. And then that means that this is going to be a two-tailed test. So we will have a critical value on the left and a critical value on the right. And when you're talking about claims about the means, we're actually going to use the t-distribution. And before I can go and find the critical values using the t-distribution, I need degrees of freedom. And degrees of freedom is just the n minus 1. So it's going to be 33 minus 1. So degrees of freedom equals 32. And then I can use the calculator to find the critical values. So go right here to distributions, second distribution, and then it's number 4, the inverse t distribution. So tell it what the area is. Oh, I forgot to do that part. So this one, I said let's use 98% level of confidence. That means the middle of the graph is 0.98. And then you can find alpha by going 1 minus 0.98. And that equals a 0.02. And then when you divide this in half to put half in this tail and half in this tail, alpha divided by 2 equals a 0.01. So this side is going to have 0.01 and this side is going to have 0.01. All right, now I'm ready to use the calculator to find the critical value. So the area is 0.01, and you could use either the left side or the right side. So I can tell it the area is 0.01, and then degrees of freedom is 32. And then when you paste and hit enter, it gives me a negative 2.449. So it's giving me the one on the left. The one on the right will be the same number, but positive. So positive 2.449 on the right side, and then negative 2.449 on the left side. And then I just noticed that I forgot to do this, but H sub O is the easiest one. It ignores everybody else, and it always has an equal sign. Okay, we're ready for the test statistic. So are we actually able to prove anything? So my claim was that the average is going to be 3.0. As you could see, it's better than the 3.0. But then again, that's only 33 people. So is that enough evidence to actually prove that I was wrong? So the test statistic . So when you go to the calculator, go to stats, move over to tests, and then it's going to be number 2, the t-test. And as a reminder, you could even write it down, we're using the t-test. And when you go to number 2, we're using stats. Data would be if you had a long list of data that you typed into the list. If you have the mean and standard deviation, that's the stats. So this first thing is saying, if you look at H sub O, what number is that? 3.0. Then the X bar, 3.28. the S 0.51, and the sample size 33. And then because this has not equals, this should have not equals. So that is set. And then skip down to calculate. And we just need this number right here, that t equals a 3.154. So then I got t equals 3.154. And the role of the critical value is to basically say anything that goes beyond this means that you actually did prove something. The 3.154 is bigger than the 2.449. That means that H sub O is false. So anything that goes past 2.449 proves the H sub O false. Also, if it would have gone past negative 2.449 on the left, it still would say H sub O is false. But if it lands in the middle, that means that we did not prove anything. This one lands far enough to the right, we did actually prove H sub O is false. Turns out the claim was the same thing, so the claim is false also. So when I said that the average GPA is 3.0, no, it's actually better than 3.0, and it turns out that this is enough evidence to prove it. Okay, then go on to the second example, and I got a fresh page here. So then this one is the college GPAs. So test the claim that their college GPA have a mean that's below a 3.0. So for the claim, I can say that the mean is below or less than 3.0. And then H1 cannot have an equals. Well, this does not have an equals, so that means that it stays the same. And because that arrow is pointing to the left, that means that this is a left-tailed test. So we're only going to have a critical value over here on the left. And then H sub O always has equals. So once again on this one, I did not say what to use for level of confidence. And when that happens, then use 95% as a default. So that means that this part of the picture is 95% of the picture. And if you do alpha equals 1 minus that, that equals a 0.05. So that means for this left tail right here, that is 5% of the graph, or 0.05. And now I'm almost ready to use the calculator to find the critical value, but first I need degrees of freedom. And that is just n minus 1. So 35 minus 1, the degrees of freedom is 34. And now I have all the information I need to find the critical value. So use distribution, second distribution, and this is the t, so that's going to be number 4. And the area is a 0.05. Degrees of freedom is 34. And then paste and hit enter. And it says this critical value is negative 1.691. So to prove anything, our test statistic is going to have to go past a negative 1.691. So for the last part of it, the test statistic and again, just a reminder, use the t-test. So go to stat and then tests and use the t-test. So this number is from the H sub O, so that's a 3.0. And then the X bar is 2.97. And the standard deviation is a 0.68, and that's based off of 35 students. And then this is a left tail, so I do need to put this as pointing to the left. And then calculate. So the t turns out to be a negative. So t turns out to be a negative 0.261. So right here in the middle of the graph would be 0, and a negative 0.261 would land right about here, and that does not go past the 1.691. So that means we did not prove anything. So do not reject H sub O, because we did not prove anything. So in previous examples, I said, well, is this 35 people enough to prove something? Well, perhaps it would be, but I was claiming that it's going to be below 3.0. And to really prove it, it really needs to be way below 3.0. It's just barely lower than 3.0, so that's not enough evidence to prove anything.